We are live. Hey, welcome again. It is vSphere Live, the YouTube channel, the vSphere YouTube channel's monthly show where we talk about all kinds of different stuff. I'm Bob Plankers. I'm joined by a variety of people. Not calling any of these guys a variety, but they're a good crew here. Ken, you want to introduce yourself?
Hi, I'm the Director of Technical Marketing for vSphere and some of the emerging technologies at VMware.
Excellent. How about you, Justin? We'll just go
Hi,
around.
I'm Justin Murray. I'm an architect on Ken's team in technical marketing at VMware.
I'm Jim Brogan. I'm the same thing as Justin, only a different instantiation, also working for Ken.
Excellent. And I'm Bob Plankers. I'm a senior technical marketing architect. I usually do security and compliance stuff. So you should patch your stuff and don't let ransomware in. There, we've got me covered. So we want to talk about AI and ML, artificial intelligence, machine learning, those sorts of things. I have to admit that I'm an old school vSphere admin. This sort of stuff is newfangled technologies and that, and I'm kind of hoping that you guys, Jim, Justin, you guys can help me understand and help everyone kind of. Let's start at the beginning, I guess. Like what is AI? What is ML? Do they relate to each other? People toss them around a lot. There's a lot of stuff that says it's AI. Is it? Justin, you had some thoughts about this.
Yeah, for sure. I'll go first and then Jim will correct me, I'm sure. I think of AI as any computer technology that tries to imitate human behavior. So understanding, learning, reasoning, that sort of stuff. Now, a subset of that is machine learning. Machine learning is about taking a bunch of data that's historical, that's happened in the past, applying it to a machine learning model, which is a computer program, and having the model understand the patterns in it, which are the important things there, which are the unimportant things there, and then have that model be able to look at a new sample of data and say, this is good or this is bad, or predict something in the future. Prediction is kind of the opposite of business intelligence, where you're reporting on something today. Prediction is saying, given all that historical data, here's what's going to happen next week with your sales, or here's what's going to happen next week with your machines on your shop floor. That's machine learning. It's taking data and feeding it into a model. AI, I think of as a much, much broader field, much more difficult field that not only tackles learning, but tackles reasoning, speculation, all the things that we humans do, understanding cause and effect. That's not there in machine learning today. Understanding commonsensical, rules of thumb, as opposed to the patterns that I've learned in the past. So the analogy for me is a child. You give it a lot of examples of good behavior and bad behavior, and then you send it out into the world and it can say, well, that's good behavior and that's bad behavior, even though it's never seen this thing before. But the child has common sense. It has cause and effect. It has a whole bunch of things that machine learning would not give it. And so that's the difference. AI is the big field of human mimicry, if you like, mimicking a human, like the Alan Turing test from the 1950s. And then machine learning is a small subset of that. That's about patterns of data.
What do you think, Jim?
So largely echoing Justin's comments. I mean, AI has been in the works for 50, 60 years. And, there have been lots of approaches. It's trying to make, it's artificial intelligence. It's trying to make a computer or some kind of machinery intelligent like humans. And I think it's so difficult because we really don't even have a good definition of intelligence. It's hard to make something that does that. They have tried rules-based approaches and knowledge-based approaches and many different things. And, if you have a computer that can write music that sounds like Mozart, it's not the same thing that can play chess. And we're always, we never quite get there. And we always find that we're not even, it doesn't even feel like we've gotten closer. But AI is all of these things that try to do the things the human brain can do. whereas machine learning is a subset of that. It takes some structure that isn't spoon-fed rules, isn't programmed line by line to do certain things. It's not even necessarily spoon-fed knowledge, or this is what a cat's ear looks like, and this is what a whisker looks like, and therefore this is a cat. It's this more of it's like a huge spreadsheet, at least a deep neural network is, where each cell can look at all of the cells in the previous column, and it can't look at anything else. And that one cell can fan out to all of the cells in the next column, but it doesn't fan out to anything else. And it's a lot of math involved in that one cell, and it can all be done in parallel. But you're just by random fluctuation gradually adjusting what that one cell does with everything in the previous column.
Yeah, to learn the pattern then, right?
Yeah, to learn the pattern.
Yeah.
And when it's finally working and it recognizes a picture of a cat, you don't know what any one cell's contribution is exactly. You can get some hints. It does look like there is line detection and inclination detection and patches of color detection in the early stages, and at the end you can kind of see convergence on cat-like things. But these middle columns in the spreadsheet, who knows?
So it's almost like field mathematics, where you have full equations that include multiple vectors that would move one particular neuron in one direction or another in terms of supporting the weight. And I was thinking, like, as you're describing that, how do we know what good looks like? Like, machine learning as part of that whole thing is what's going to then ultimately tell you what that cat looks like. How do you train the brain of this AI or how does ML work in order to say, okay, this is a whisker, and you look at it and say, dude, that's a paw. What are you doing? How does ML actually train itself in order to get closer and closer to catness, or the essence of the cat in the Platonic sense?
Well,
the form.
There are different approaches to training. One where you don't tell it if it's right or wrong. You kind of categorize things. But the one that's easy to understand is you have someone already known to be intelligent, say one of the three of us, that identifies a picture as a cat, and then you fill up this spreadsheet with random numbers or ways of multiplying previous cells and adding them together. You seed it with random stuff, and then at the end, that last column is supposed to have one cell that corresponds to cat, and another cell that corresponds to dog, and another cell that corresponds to dragon. And you look at the dog value and the cat value and the dragon value. And if the cat value is low and the dog is high, then you sort of go backwards through the cell and just barely tweak the numbers to bring down the dog value and to bring up the cat value and to give the dragon an imaginary number. And you just do that with lots and lots of known pictures of cats. And after you've done this 100,000 times over the course of 3 days, voila! Suddenly, it's very reliable at identifying the cats. And you don't know exactly what you've done, or other than just
zone.
Yeah.
What have I done? Yeah, I think because that's a lot of the exposure to AI sorts of things, at least in science fiction, is a kind of what have I done sort of aspect to it, the post-apocalyptic thing. And, Justin actually, and I don't, Justin's having computer issues, I suspect. He was having them prior. So apologies to our listeners.
He may have finally achieved that AI overlord that has destroyed him.
Yeah, like we're talking too much about AI, so it had to cut him off. But yeah, I'm sure he'll be back in here. But and it does remind me too, if you've got questions or thoughts, there's a lot of good commentary going on out in the various chat sections here, especially over on the YouTube side of things. Feel free to ask questions. We'll answer them live as we go. But where I was going with this was Justin had kind of kind of the what have we done thing here. Justin had kind of hinted at uses for this stuff. Like who's using these things. Jim, do you have any insight? What are people using this stuff for? Like, Justin had mentioned, business analytics and things like that. But there's got to be, what else is there?
Everybody, as far as I can tell, is finding uses for this. And part of it is because they'd rather pay a computer to do something than a human, especially when the humans get tired or are known to make mistakes or go on vacation. And in some cases, perhaps it's more ethical to have a machine do something than a human who would bring into it baggage or things that you don't want. But Justin, I think, mentioned things around financial services, but in manufacturing, you'll want to control the inventory. You'll want to see if things were manufactured correctly. If there are flaws, you want them booted out. Perhaps
so would that be machine learning, the predictions of that sort of stuff, or are we talking AI, or what is this stuff?
Everything today is pretty heavily in the machine learning camp.
Okay.
At least, those applications that are using GPUs. I talked about this spreadsheet, all of this math, since it's not really in loops, it's not heavily sequential. You can do a lot of these things in parallel with the same kind of matrix multiplication or matrix operations that are used to throw pixels on a screen. I think it was around 2010 that frustrated professors at Stanford said, hey, this math that we're doing that runs so slow on a CPU is exactly the kind of math that the GPU does to let us play Grand Theft Auto. Or I'm sorry, these Stanford professors were probably playing Doom or something.
Yeah.
But I'm not sure that's better. I'm not much of a gamer. I can't come up with a better example.
Yeah,
where was I going? So all of this math can be done in parallel, and it can be done by GPUs. And
you couldn't go with a flight simulator. You couldn't do something.
Flight simulator. There we go.
No,
that's what they're doing.
That's why we have Ken along. Finally, yeah. Somebody name a game. Oh my goodness.
It's my time to shine.
I kind of forgot where I was going, but
sorry, Jim. Yeah.
So all of the applications that are using these GPUs do so because it turns out that manipulating pixels is the same kind of math we need to do the machine learning. So now that we can accelerate it 100-fold or more with the GPU, that's the hot market, or that's the hot method. So I've mentioned manufacturing now and financial services, but take medicine. You want to look at an X-ray and determine if someone has cancer in their lungs or something.
That's the thought that I had when you said, somebody who's tired, somebody who's, like all these radiologists out there looking at this stuff that, might be tired. Maybe they're hungry. It's time for lunch. Maybe their eyeglasses. I know I need to get my eyes checked, and, maybe they do too, they're the ones that figure out if I have lung cancer,
And is an individual person good at looking at every quadrant of a lung? I mean, maybe, we read from left to right. Maybe they identify, 10% more cancers on the left than they do on the right side, just because of the way they learn to read. I
think there's more to it than even just image recognition or pattern recognition. I think beyond that, it's finding data that it's finding the pattern that isn't necessarily even something that you might overlook. I think we're coming at that from a negative perspective, saying that maybe they're better at seeing things than we are, but they're also better at finding data sets and patterns and things that we just would not be able to observe at all.
Yeah.
So when you talk about medical imaging, medical diagnoses, things along these lines, well, what about just Google searches? Can we find, I was reading a commentary this morning about it, was saying, I wonder if we could have determined COVID based on Google searches for flu symptoms and coughing and
Yeah.
things along those lines. And this is where ML, I think, can step in and assist in ways that we haven't even thought of yet. And that, to me, is the really cool part about this whole field. You mentioned 2010, like, it's such a nascent field. It's been around. The math has been around for a while, and they've been slowly iterating on it. But in terms of mainstreaming AI and ML, we are the infants that are crawling around at this point, I think, in terms of some of the applications for this stuff. And I think that this kind of ties in with Himanshu's question about why does a VI admin need to care about this? This isn't some esoteric, field preserved for the Stanford nerds. This is something that's really going to affect every bit of data that's out there. And as we all know, that data is being generated at an ever increasing rate too. So what do we do with that data? And I don't think we even know what we're going to do with that data yet at this point.
Yeah, I think things are deployed in the real world, but I think we're just seeing the tip of the iceberg. The number of applications is going to grow and grow and grow. You can use this in automotive. We had one client who wanted to count head of cattle as they were unloaded off of a truck. Nice. It is top to bottom, everything, the good, the bad, the scary, and all the things we expect from a modern society. It's all going to be there.
I had an interesting conversation with a guy at a hotel bar one time, actually. Just, how are you doing? I'm all right. What do you work in? Oh, I work in physical security and AI. Okay, how does that work? And
image recognition and
image recognition.
facial
So
recognition.
the first thing that they could do is start scanning to determine whether or not that person with the trench coat is carrying something under his trench coat, just based on image patterning. And the second thing was, well, what is it that he is carrying? And that is a gun. And what sort of a gun is that? That's going to be a very bad situation. We need an instantaneous response. Versus, no, it's just cold and rainy out. Leave the poor guy alone. Things like that. So stepping in based around image recognition, but also response patterning based around those images that they're recognizing. And I thought, man, there's already a field for that. And this is relatively static data. When you think about images, they tend to be fairly large, but they're not super dynamic in terms of how rapidly they're changing. So
what are
there are a number of uses in retail. Hopefully a large number of them will make the shopping experience better. Wouldn't it be nice to just go in and shoplift everything, and then it just shows up on your Visa bill correctly listed?
Amazon stores that are like that, where you just can walk out with stuff and it bills you.
I believe so. Although I haven't gone there, or I haven't gotten the bill.
I bet they discontinued them with masks. Yes, but
or no one comes up and says, "Can I help you, sir?" Until you're looking around like, "Hey, would someone come and help me?" And leave me alone until then. But there are safety concerns. Has an accident happened in aisle 54? Is something stacked too high? Are the shelves not stocked well? Are we out of potato chips? That's important. And then there are people who are truly shoplifting or running scams with the barcode. You take the barcode off of a loaf of bread and put it onto the large screen TV, and then scan it. You want to recognize what's actually going through the checkout counter and see if it corresponds. There's all kinds of uses.
I wish they would do that. Oh, I'm sorry. Go ahead, Ken.
It doesn't require you to shove RFID tokens and tags into your oranges either. So it's
it turns out that increases the costs of things, as well. Not to mention molesting an orange to add a piece of hardware to it is just not cool, But
what I don't like is the 3 minutes it takes me when I have wet fingers to peel the label off my apple before I
peel the label off. And I wish they did that, because I hate the weight sensors in the self checkouts and that. If I don't want to bag something, don't let me. Who cares? Or if I move something around because the whole area is full, and now all of a sudden I need help from a human. Come on, that's just wrong. But
I hope
Justin,
Tesla
good to
is
see you
watching.
again, pal. So
Yeah, sorry about that. Machine reboot.
yeah.
Should we go back to Himanshu's question a little bit?
Yes, let's do that,
we
please.
deleted the answer.
Yeah, and I
Um,
actually put in the chat that we would get back to it here.
Yeah.
You know, so what is a VI admin? What is a vSphere admin? Why do they care about this stuff? You know, like what do they need to know? I think we're working on what I've got some other questions here. What they need to know, but why do they care about it?
and I think we should force Justin to answer since he's been absent for so long.
This
Okay.
is penance.
So the first thing a vSphere admin is going to hear is somebody in their company saying, I want to do machine learning and I want to use GPUs. And I'm going to Amazon if you don't give it to me. That's one thing. Then they're going to say, I need very high speed networking because I'm going to be retrieving massive quantities of data over the network, or I'm going to get 2 or more computers working on this job together. And I need ConnectX 6 cards from Mellanox at 25 gigs or 100 gigs or 200 gigs between those 2 machines. So these GPUs and high-speed networking cards are not new to VMware. They're understood by VMware. We can deploy them in several different modes. Jim will talk about one mode. But if you're okay with the GPUs being on the very machine on which your virtual machines are running, then what the VI admin has to be concerned about is how many GPUs are there? How am I going to present them to the VMs? And it's relatively straightforward. You know, we've been virtualizing CPUs for 22, 25 years in VMware. We've been calling them virtual CPUs. Well, exactly the same idea applies to GPUs. A virtual GPU is just a representation to a VM of part of a physical GPU. And therefore, 2 virtual machines can share the same physical GPU by having half of it each, maybe half of its memory, and half of its memory is presented to the VM as a virtual GPU profile.
Cool.
So that's the basics. vGPUs are just like vCPUs. You can vMotion your VM around, even with a vGPU attached to it.
Oh, really? That's fairly new, isn't it?
That's been around for a little while, but it's getting,
Realize I'm old school vSphere admin, so GPUs. That's I might ask.
In that case, it's brand new, Bob.
It's a great question because vMotion needs a little time to catch up the memory. Traditionally, the memory of one host with another. Well, GPUs have massive quantities of memory on them. It's called frame buffer memory. Frame buffer is just a word for GPU attached to memory, onboard GPU memory. And now if you vMotion a VM that's using 80 gigabytes of frame buffer memory on GPU A, if you vMotion it to host B,
it's got to copy all of that.
Well, at some point, either asynchronously in the background or right now, it's got to have some time to copy that data. And so we say to people, don't put more than 4 full physical GPUs on a VM today for just that reason.
Okay. That makes sense. I mean, a lot of this stuff kind of sounded just like a sizing sort of thing.
Absolutely.
You know, like why does a VI admin care? Because they have to size it, and to your point, make sure that everything is working because they're on the hook for all those interconnects, right?
And I gave you the reasoning about sharing a GPU. You don't have to use sharing to use VMware for your GPUs. You could say, well, this is a high-end data scientist. He needs 2 GPUs all to himself or herself. He needs 4 GPUs all to themselves. That sometimes happens, and we can do that. We can present 4 GPUs to a VM without a problem.
And we've got that flexibility to cut that up.
Yeah.
So you had mentioned that Jim was going to talk about a different mode of operation here. What is that mode?
Everything I've described to do with vGPUs is where your VM and your GPUs are in the same box.
Okay.
That's an intro to Jim's idea.
Yes. Yeah. A big lead in here to,
Ta-da.
Okay. So we also have a product called vSphere Bitfusion. Bitfusion was a startup company and which I worked for, and we were acquired a couple of years ago. And Bitfusion's value proposition was to increase the utilization and efficiency, and we have two different definitions. They mean different things. The utilization and efficiencies of GPUs, because they're expensive, and you really want to be able to share those GPUs. There are many inference applications where you don't need a full-sized expensive GPU. Your data will fit in half or a third of the memory, and you're not using all of the compute all of the time. And it would be nice to let multiple users run their applications in parallel, which a GPU is perfectly capable of doing. But the other thing we did is allow applications on remote machines to use those GPUs.
That's right.
So as an application is running, and it's running it's a machine learning Python script, and then it imports TensorFlow, and then it imports an NVIDIA deep neural network library, and eventually it's making CUDA calls. It's actually accessing the GPU with NVIDIA's CUDA library. And what Bitfusion does is it allows that application to run, and as it makes the CUDA calls to access the GPU, Bitfusion intercepts those and sends them to a remote machine, which has been previously has allocated some number of GPU or some number of GPU slices, and the rest of that software stack, the rest of that application, the part that works with the GPU will execute on the remote machine, and then all the results are returned to the first machine, which goes on just as if it had a local GPU, never knowing that Bitfusion interceded on its behalf. So this allows you to run any application, dynamically allocate GPUs or slices of GPUs, run your application, and when you complete, if it's not in a forever loop, when it completes, then it will deallocate the GPUs, and another application, another user on another machine can immediately allocate and use those resources. No VM has to be brought down to reassign those GPUs. The Bitfusion server that's on the host with the physical GPU stays up all the time and is the actual owner, the permanent owner of the GPUs, but just acts as a service to the clients where the applications are running.
That's really cool. Go ahead, Ken.
I was just going to paraphrase that and summarize both of those models then. So on the one hand, we have very high performance local access from a VM to a GPU, and you would probably do that for high performance requirements, things along these lines. On the other side, we have Bitfusion, where we would have remote access and partial sharing and things along these lines. I'm assuming with a little bit of latency added on for the network purposes. So you get the flexibility with Bitfusion and the performance with local, and those are kind of the two different options. Is that a fair?
Yeah,
Yes.
local and remote is a good way to put it. And, the local one that I described, the virtual GPU one that I described, has exactly the limitation that Jim pointed out, which is to change something, you've got to bring your virtual machine down. That's not the model in the Kubernetes world, where you have stateless virtual machines that come and go all the time. So Bitfusion is friendly to the Kubernetes world, where the clients are outside the pool of GPUs effectively, and they are independent of it. And whatever happens in GPU land is independent of what's happening in application land.
So let me ask another architectural question. How does any of this fit in with Horizon? Because that comes up a lot.
Yeah.
You want to go first? I should certainly say something on the Bitfusion side, but Justin, do you want to talk about Horizon first?
It's certainly the case that people are using GPUs today for graphical applications via Horizon, AutoCAD, designing buildings, designing vehicles with applications like AutoCAD that run on a remote desktop. That's a different kind of application to the machine learning applications that Jim and I spend a lot of time on, which are compute intensive, but not graphics intensive. Now, the complexity is the two get mixed. For example, in the medical imaging application world where ML is famous for being as good as, or maybe even better than radiographers at reading images. You're talking about three-dimensional images, but you're doing compute-intensive analysis of it. All of that is possible through a virtual desktop as well. It's a different type of use of the GPU, using it for nice graphical display or ray tracing and all of that wonderful imaging world, and using it for the compute intensive, the matrix multiplication that's inside the machine learning model. There are different uses. You'd use different profiles for them.
So if I had a vSphere cluster with sufficient hosts and sufficient GPUs, I could presumably then serve a virtual desktop infrastructure for that kind of requirement, and my ML compute intensive workloads, but they probably couldn't share the GPUs at that point, I would assume.
There would be separate profiles in the virtual GPU world. Yeah.
Yeah.
Or maybe even separate dedicated GPUs in the same box. Yeah.
And with regard to BitFusion, we do draw a hard line between the graphical use cases and the compute, the machine learning use cases. BitFusion is only aware of the CUDA API calls that are used for compute. The graphical APIs that NVIDIA provides to throw pixels up on a screen is invisible to BitFusion. So BitFusion is not suitable, not designed, won't work at all, to put it more bluntly, with the graphical applications. It is for the compute applications that use CUDA.
That makes sense to me too, just given the premise that you're going to be contexting in and out of GPUs fairly quickly for math purposes. That's a very different architecture from an I/O perspective. So.
It's a great question though, Ken, because we get a lot of queries from our field folks saying this customer of mine is doing something with GPUs. They're a design company and they're doing something with GPUs. Therefore, machine learning fits in, right? And maybe not always the case. Their GPUs are dedicated to presenting graphics in a nice ray tracing way, and they would have to be altered somewhat to do machine learning. At least the profile we use in the virtual machine would need to be.
So what kind of GPUs are we talking about here? We're talking about what I can't buy at all right now, like, something for my desktop here, or I tried to buy a GPU the other day and I was like, oh, maybe I'll wait. But or are we talking, is this specialized stuff? Are there server versions of what I'm looking at on the desktop? What is this stuff?
Yeah, I'll answer first, Jim, if that's okay. There's the GeForce type of GPU that you get in your games machine that does wonderful displays and everything. And that
my flight simulator fast, yes.
Yeah.
You were gone. I'm sorry. We were struggling to find a game that a Stanford professor might play in 2010. So anyhow, inside joke. Please continue.
That might be something to do experiments on, and you could experiment with running that out of Fusion or Workstation or one of these things.
So I could start this stuff. I could mess around with it on my desktop and using some of these same techniques.
Mess around with it, but we look at the enterprise side of GPUs, and that's the Ampere A100, A30, A40 type GPU, or the V100 GPU that's more than $1,000, to be quite honest. And it's,
I think the desktop ones are as well now.
Yeah, and those are big machines with big memory on them, because these machine learning models are growing by the day, if not by the month. We're hearing about models that are billions of parameters in them. So they place a premium on memory. There's 6,000 cores in an A100, but
holy buckets.
If you run out of the memory that you have on your frame buffer memory on your GPU, then your alternative is get another GPU into the same box, or get another box with another GPU in it and do distributed work like that. So, yeah.
Now,
how much RAM is on those things?
The frame buffer
100. Yeah, how much frame buffer RAM is on there?
Frame buffer memory.
You mentioned like 80 gigabytes, and my mind just sort of like had a mini blow up here. Like, wow, that's a lot on a GPU. What is it?
It is. It's actually, that is the RAM on the GPU, is the frame buffer memory. So that
A100,
yeah, the 80 gigs is probably the biggest model we see right now. But that's going to increase. That's going to get bigger because, one of the most famous high-end machine learning training examples is called GPT-2 or GPT-3. They use hundreds and hundreds of machines inside Google to run just that model.
Now, a GPU like a T4, which is a more economical edge case, inference case type of GPU would have 16 gigabytes, not 80. But
so let me come back to what you just said there about edge use cases and so forth too. Obviously, we hear a lot about data that's being created at the edge. You have our famous one was what was it the power generator? I don't recall what we were showing, running things like ARM and so forth over the edge. The amount of data that the world is creating is predominantly, it seems, from the trends that I've seen, being generated at edge, remote sites of one form or another, instrumentation that we would otherwise try to throw the data away with. I don't know if it strikes me that the support for vGPUs and AI and ML and all the rest of this stuff on vSphere makes that to some degree easier, because we can now throw VMs, common infrastructure, stuff that we can manage centrally out at those remote locations. We have things like vSAN, which make it easy to store that data. But what types of workloads, I don't know enough about the AI workflows themselves and the ML. What do we do with data in terms of that sort of massive amount of information that's being created? What type of workflows could a vSphere admin say, hey, I know just the thing to help out our edge data proliferation? Is there something that we could do in that space?
Yeah, there's a variety of things. A couple of servers on a factory floor monitoring all the sensor data and making predictions about what machine is going to need maintenance next week based on the heat sensors, for example. Something's overheating. That's a classic example from manufacturing, or oil wells that are out there in the sea and don't have a data center nearby.
Or retail cases that we were discussing while you were absent. Yeah.
Right. All of those could be doing local inference on those local servers, or even on a camera in an airport. Local inference to the source of the data and not transmitting that data over perhaps a not very good connection to a big data center.
So it's a data reduction model.
Yeah.
And inference is predictive. Okay.
There's a very interesting example, again, from Google, who are sort of doing fundamental research in all of this, of federated learning. That is, each of us has a cell phone and we have some private data on that cell phone. And that, where we go in our searches or such like is private to us. But you could put TensorFlow on a cell phone and have it learn what the patterns of the user behavior are. And then feed just the data about those patterns, not the actual private data, but just the, if you like, metadata or gradient data or the weights that compose your model. Feed that data back to headquarters and reconcile that across 1 million phones to average it out, if you like, and see where the patterns are in all of that. That way, you're not sending any private data anywhere. This is just weighting data that says, well, zip code is really important to this user, or age is really important to this particular purchase that is made. So that sort of weighting data is independent of the user, but it helps train the model centrally. So now a model is being used on a cell phone, but it's also, or a remote device of some kind, but it's also being downloaded regularly from headquarters with a newly trained model.
So now when you're driving your car, you could say, if you took a right turn at Central Avenue, you may be interested in the sale on milk at Safeway.
But you can only turn left because
That's right. There's a new sign there.
or we've seen the way you turn right, and you don't want to do that, trust me.
I personally want to stop waiting at traffic lights because there's nobody coming from left and right. It's it's 5 a.m. I'm on my way to somewhere.
Yeah, what if the traffic light could actually just make a decision on its own?
There is no traffic here. Let's
Yeah,
safely
there's no-
let this guy through.
Yeah, and there's a dude coming, and before it gets to before I have to sit on the induction sensor or whatever there for a minute and let the timer cycle through, maybe it can see me and maybe it knows I'm coming. Maybe.
Or if you're so rude as to not have a cell phone with you, then it could keep the light red for 10 minutes.
Yeah, or maybe I'm an ambulance and would like to be let through because somebody's dying.
Right.
Because people are cheating there are ways to cheat because normally it's a strobe thing that they've got to trip the lights and make the lights change, and those you can get a strobe yourself and cheat. Strobes have negative properties for people who are like epileptic and such, and so, being able to just detect an emergency vehicle and let them through, that's actually kind of a cool idea. But
Yeah.
you had mentioned something about, you've mentioned some things about training models here. A question that was sticking in my mind, and by the way, if you're out there watching this, thank you for joining us. It's wonderful to have you. If you've got questions about AI and ML, we've got experts here. Please put them out in the chat, and we'll see them. We'll answer them live, and really appreciate this. So you can subscribe to our YouTube channel as well while you're doing that, so that you get notified of more vSphere live sessions like this. But back to my question: these models. So these data sets are big. These models are big. Do you need to retrain them all the time, or can we store the model once we've trained one of these systems? Can we store the training data somewhere so we don't have to do that again?
Absolutely. And there's a whole science around that particular angle.
I bet.
Called transfer learning. That is,
Oh, really?
do I actually need to train my model from scratch at the beginning, from no data at all?
For example, if the early columns of our machine learning spreadsheet are already good at detecting edges and lines and patches of color,
we don't have to figure that one out.
we don't have to. Yeah, I mean, why should we start over there?
Right. And you ask a second great question there, Bob, which is, does the model get stale in production and need replacing, updating, retraining possibly? Mm-hmm. And absolutely it does. In fact, the important thing is once the model's in production, in inference, doing real work, doing the payoff work for your business, then is it doing the right thing? Is it saying Justin is a good candidate for this mortgage or not? Is it making valid predictions or classifications of what's happening? Is it correct? Is this model correct? Because the data that this model is seeing in production may be skewed somewhat from the data it had in training. It might be different. And so is it handling unknown situations well? So that quality assurance on a deployed model is very important. And the result is the model's got to be taken back to headquarters and retrained on new data.
Well, the other thing is they're constantly adjusting the models. I mean, the model with 1,000 cells in a column and 100 columns might get placed with something with fewer columns, but more cells vertically, and the little math that each cell does can be tweaked, or the way it's activated and decides to propagate or not its value to the next column. All of these things are played with all the time. So recognizing a cat with 95% accuracy with one model, you might bump it up to 97% with a new model, and you'd have to train that new model.
And there's a great term for that, what Jim is describing. It's called hyperparameter tuning. And you can make a living. You can make a living doing that today.
Oh, I bet, because it doesn't seem like much, at 2%, but 2% at scale for a lot of the companies we're talking about doing this stuff, that's billions of dollars sometimes,
Absolutely.
or
it's 10% faster. It does the same job.
Oh, true,
but,
true.
The new model is much faster.
And I read an interesting study on this where they were talking about very confidential data. If you imagine that, and they're in a ring, so they couldn't do too much testing and flaky around with this stuff because that data had to be protected. So they had, as it were, an extra ring around this data where they did all of their training, all of their modeling, everything happened out there with data that was in essence scrambled and
Obfuscate.
anonymized and obfuscated completely. And then they did their training and this extra ring. And then once they had done that training against the model, then they could bring the model in against their confidential data without having to leak data out in order to just iterate their training and their inferences. And I thought that was a pretty good model. And again, running that on VMware made that pretty easy for them because the models are completely portable across the same OS, across the same VM instance, things like that. So.
And that just reminded me of there's a whole field of encryption study right now about being able to do work on data, on encrypted data, without ever knowing how to decrypt it. So if you want to feed it into a model or something like that, like how can you do this well where where you don't, how can you change that data? How can you work with that data, but never actually know what that data is? It's a really strange and interesting field. And so, sorry.
Yeah, it's sort of like a Philip K. Dick novel, I think.
Well, all of this stuff is sci-fi, and I looked it up when we were scheduling this. I looked it up, and Wikipedia Wikipedia says that the first mention of something that was artificial intelligence-ish was 149 years ago, and so we've been dreaming of machines thinking for us for a long time, clearly, and then, of course, all the sci-fi stuff is like post-apocalyptic, AIs. Justin, you were talking about AI not doing what it's supposed to or figuring out, is it doing it right? There's a lot of discussion around that, around, the ethics of some of the stuff, ethics of training these things. How did we train these models? I mean, we can skirt some of that because we're talking about infrastructure, but that's, for these companies that are doing this stuff, that's a real concern,
That's a very big subject in itself, bias in models against or for some group of people. So that needs careful study. If I'm using an AI model to determine whether somebody gets a bank loan, then I'd better be able to explain how that model reached that conclusion. What were the important factors in that decision? Because a regulator is going to come by my office and say, explain your computer system to me.
Well, I think that's one of the interesting things about this whole thing too. We can put AI in charge of ensuring that equity, inequality, and inclusiveness is being met by AI. I mean, literally,
I've never thought about that.
Quis custodies, right?
Yeah. In fact, you hit it on the nail there, Ken, because with neural networks, these complicated models, which have hundreds of layers in them, it's very difficult to explain actually what's going on. But by comparing the outcome from that model with another simpler, mathematically oriented model, classical statistical model, there's a possibility that you can say these two models behave the same, so I can offer the simpler one as the explanation. So yes, using AI to monitor AI.
Very Holmesian.
Yeah. Oh, the wolves can watch the wolves watching the sheep. Yes.
And we're back.
Like I said, I'm a security guy, so I'm a permanent pessimist.
I have seriously though seen a presenter from a financial institution say, "Explain your model to me and how it behaves, or else it's not going to production."
Hey, we've got some questions coming in. I want to start with one here. Do we really need to manage AIML for our product services on our private VMware infrastructure? I think I would say, well, you don't have to do anything, but we are working very hard to make it easy to do that. I don't know, Justin, Jim, Ken, what do you think?
Yeah, I think there are valid reasons for doing it on your own infrastructure. One of the reasons that's been given to us is I need full control. As you guys were mentioning, there is private data. That data has got to stay in a particular country or in a particular walled environment. And some folks say, I prefer to do it that way. Other reasons are, I'm going to use this GPU pretty heavily. I don't really want to pay for it as a service. I'm going to be using it 24/7 for 4 weeks while doing training of a model.
Well, and bandwidth and
that
data.
That kind of gets expensive.
Yeah.
So there's a lot of...
And all the data has to be moved out as well then, if it's not private.
There's a lot of work going on in ML in the cloud, that's for sure. It's probably the bigger portion of the world today, but there are a lot of people with VMware data centers that are full of applications, whatever those applications might be. And those folks are coming to us and saying, Is it possible to do machine learning on these same machines? And it is. We've kind of taken the approach that we'd like to democratize that workload and make it available to everybody in the data center as just another workload. Now, it's got some unique requirements, GPUs, high-speed networking that we can take care of. But there's no reason in our minds why you shouldn't treat this as another managed workload in your data center, like you do your file servers or your mail servers or other applications today.
Well, and to me, go ahead, Jim.
I was going to say, and I think the edge case, by definition, is we're talking private infrastructure.
Yeah.
I think, sorry, Bob, go ahead.
No, go ahead.
It's really a hybrid model like any other hybrid model. There are advantages to running on-prem. There are advantages to running in your private infrastructure. There are advantages to running in a public cloud. Optimally, it's like Tanzu. Do you care where the application runs in and of itself? Probably not, or you shouldn't. Unless you have a reason to care where it runs, at which point you probably want to have some flexibility in where you want that running. Yeah. So optimally, something that's compatible across all of those different implementation architectures is going to be the most flexible.
And we've trained things in the cloud and deployed them for inference on premises, or trained on premises and deployed into the cloud. It's applications should be able to move like that. Is how. Yeah,
it's a bandwidth problem, honestly. At that point, that's what it sounds like. The other thing I was, go ahead. I'm sorry.
Sorry. What actually moves in machine learning is the parameters of the model, not a big chunk of software. What's important to move back and forth between public and private cloud is not a whole bunch of software. It's the trained model, which is a set of gradients or weights or parameters that you're going to move between one runtime and another.
Cool. Yeah, I was just going to say, too, from a vSphere admin perspective, you talking about another thing to consider as part of a data center's workloads and applications. I was just thinking that, if you're buying new hardware, sizing for the inclusion of GPUs or the inclusion of GPUs straight up here, it's another thing to worry about. But, there's, when you're buying servers, especially, like there's some choices you can make about internal wiring and PCI buses and stuff like that make it really easy after the fact to go and add GPUs to clusters and things like that. And that might be something to think about for folks to think about as moving forward is, like even if you don't have a need right now, knowing that the lifespan of a server in your data center is going to be 3 to 5 years, that's the time horizon. Are we going to need this stuff in that time horizon? And, then. Yeah, probably. It sounds like the answer is yes. Yeah. Hey, we've got another question here, which is great. If you've guys got questions, we've got a few minutes left. Let's answer as many questions as possible. Have you guys ever worked with radiology standards to virtualize the image reading process? We've mentioned it a little bit here, but maybe you guys can talk a little bit more about it.
Yeah, there is a standard in medical data storage called DICOM, digital image for medical. Forget the rest of what the rest of it means, but DICOM. And we have worked with that data. In fact, we used pre-trained models from a framework from NVIDIA actually called Clara, which understands DICOM. And that's able to read images of X-rays, images of CT scans, images of other devices, and transmit them around for machine learning to work on them. So there is a heavy overlap between medical imaging and machine learning. That's for sure. In fact, some of the university hospitals close to me here in San Francisco are using that very same software to help imaging and radiology and other applications in medical. That's a really worthwhile application of ML, machine learning.
Very cool. I was just reading something about how we're starting to catch cancers faster, and in fact, the article didn't even mention AI or ML or anything.
Diagnose, I hope, not catch.
Maybe. Well, I think we caught it already. Yes, but diagnose cancers, detect cancers, perhaps is even better. But in fact, I was thinking about it as you were talking here that article didn't even mention AI or ML and the ability to diagnose and treat, that a lot of these cancers are a lot more curable when you catch them so early like that. And I think it's really interesting. I've got a lot of cancer history in my family and stuff like that. So, you know, if I keep coming back to cancer, it's because, like, you know, one of the ways I'm probably going to die, that sort of thing. So the more,
the thing I
the
love
more we
most
can
about these things is how uplifting our conversations are.
yeah, but no, these are good questions. You know,
In answer to Joseph Young's question, though, I would check out ngc.nvidia.com. NGC stands for NVIDIA GPU Cloud, and look up the Clara framework there, and they may have interesting technology for you to look at. And all of that works on VMware if you happen to be a VMware user.
And Jim, unless I'm mistaken, that's one of the benefits of Bitfusion, again, is just intercepting the calls of whatever sort. So whatever the application type might be could be distributed appropriately.
That's right. We are agnostic towards your framework, TensorFlow, PyTorch, the application sitting on top. Nothing, the application, the framework does not have to be modified, doesn't even have to be recompiled. We just interpose ourselves on that software stack. And
So
existing
virtualizing-
applications, the work others have done, can just be used as is.
that's really
VMs,
cool.
just as long as it runs in a VM pretty much, and it's one of those supported frameworks. Then okay.
Yeah. Well, and for Bitfusion, the GPU servers, the Bitfusion server, does need to run on a VM, but we are very lax as to where the application runs. I don't know if you want this advertised, but it's already been published. You know, but
I suspect you're going to.
The application can run on bare metal. There's lots of reasons you wouldn't want to do that, but if in the middle of a transition, it can. The application can run in a container. So there's not even any licensing for the client side where you're running the application.
Oh, that's really cool. That flexibility is huge, you know, not getting in the way of use cases and that. That's really cool.
Yeah.
So, one other thing that I had kind of sticking out, if you've got any questions, if you're watching and have any questions, now's the time. I've got one more question, really, you know, about the machine sizing. Again, I'm a vSphere admin, you know, like supported workloads for many years as a customer in an educational environment and that. And, you know, that we were starting to just think about this stuff when I became a VMware employee. And so thinking about what are things I really want to ask, what are things that vSphere admins and people that are looking to the future with this stuff really should consider about their environment. We talked about hardware sizing, you know, like making room for GPUs, even if you don't put them in there. What are other things that people, I don't want to say should worry about, but should consider as part of their design, even if there isn't a demand for it right now?
Yeah, I would say if there's already machine learning going on at your site, at your enterprise site, and it's getting sophisticated, people are talking about expanding to distributed machine learning, distributed training, or some such thing, then pay attention to the network. Pay attention to the speed of your networking cards. It's okay to go with 10 gig to begin with, but if people are getting serious about spreading the work for one machine learning application across 2 or more servers, have a look at the Mellanox networking and see what's being advertised there that I see as ConnectX 6 and ConnectX 5 type Mellanox cards, high-speed networking. So that's
a lot of the Rocky stuff as well, you know, those really advanced things.
That's right.
There's a lot of cool stuff going on there.
And there are at least 3 ways of using that on VMware: paravirtualized RDMA, Rocky, and just straight pass-through. So there's many ways. So that's the second sort of angle of acceleration on top of GPUs. But mundane things like, do I have the right risers in my servers to take a full-length GPU?
You get bit in the duff by that stuff, you know, like it's the difference between being able to use a server or not, you know? Like,
Or what exactly is the data that my enterprise is using? Is it tabular data that Jim has referred to in rows and columns of data? Or is it more graphical or voice data, which are sort of computer vision and natural language recognition get all the attention in machine learning? But there's a huge amount of machine learning that's applicable to the tables in my database. It's not fancy data.
Payment records, transaction
records,
records.
billing records, employee records, whatever is stored in databases. That too can be used for machine learning. And you don't have to use a neural network on it. You might use a well-known model like XGBoost, which is a decision tree thing. And a few years ago, I would have been saying that sort of classical statistical model doesn't need GPUs to be high performing, but the world has changed, and GPUs are being used to accelerate everything now. So
yeah, why I can't buy a GPU myself? That and Bitcoin. But
ask your end users the question: what is the nature of the data that's important for us to do machine learning? Is it sort of graphical data, voice data, or is it tabular data in relational databases? And what is the quantity of that data? And the quantity of that data doesn't have to match my GPU memory that you talked about, Bob, because I'm going to batch it into batches and feed it into the GPU.
But just starting to think about this stuff, this is something, again, a vSphere admin, I don't know, whatever, and being caught unawares and, a year and a half into a deployment or whatever. I always hated that,
I would
One,
say,
it's an excuse to ask for more hardware. That's really cool, but if we can position ourselves better to start with.
the very high end or the very high end of machine learning, A100, no doubt, if somebody is really at the top end. If somebody's in the middle, A30 or T4 type GPUs, and if somebody's doing fairly small work or inference work only, then the T4 and such GPUs are the right thing, and they're very cost effective.
I'm very keen to hear Jim's take on this, given that he just finished a sizing exercise on for vSphere admins on.
So now I have to sound like I know what I'm talking about. Exactly. Well, my approach or conclusion, or a little combination of approach and conclusion, is that central or the ground level consideration is the GPU. Figure out how much GPU power you need and make sure that the GPU is the bottleneck. I mean, that's where the computation is happening. That's where the results are coming from. And if that is your bottleneck, then everything else is fine. You don't want the GPU sitting there idle because the storage is too slow, because memory is too small, because the network doesn't have the bandwidth you need. Or there's too much network latency. So you want the GPU to be your bottleneck, because something is going to prevent it from running at infinitely fast, and the GPU should really be your limiting factor. These programs that use the GPU as an accelerator tend to run just fine on any CPU you're likely to consider or anyone's willing to sell you. So, but on the other hand, make sure you have enough cores on your processors to handle everything. Maybe 4 to 8 cores per GPU should suffice. Make sure you have a little spare room. You'll have to take a look at your application and see how much active memory it's going to require. But, double that, multiply it by 150% to size up the memory. Make sure you can, if some applications may be sensitive to the NUMA affinity, others may not. But if you can keep your processes and your GPUs on the same NUMA node, you're good. And if you can keep the network cards again on that same NUMA node, that is to your advantage. I wouldn't consider anything below 10 gig, and at this stage with the power of these
is so cheap now.
GPUs, yes, I would unless you're just so cost constrained and you're running a proof of concept and you'll go bigger later, I'd go right to 25 gig as a minimum. But I have found in all my testing that if I stick to the 10 gig or higher network, if I make reasonable assumptions on the memory and the core use, the GPU, it's easy to make the GPU the bottleneck appropriately without draining the whole bank account.
Nice.
With Bitfusion, the network is a bigger concern than with local GPUs, because you have the application running across the network to talk to the GPU. let me take a side trip real quick on latency. A local PCI, a GPU on a PCI bus is going to be much lower latency than a GPU across the network. And a lot of the intellectual property, the IP of Bitfusion, was dealing with that latency. There's nothing we can do to Einstein's equations to make anything go faster, but we
Create
can.
a wormhole between, yeah. So,
yes, we tried that, but we had to abandon that experiment.
The
we were
researchers
losing
got sucked in
engineers.
and we've never seen them again. Yeah.
It's still going the same velocity through the wormhole. It's just that you folded time space around. That's all.
Well,
So
yeah,
it's
that's
going
what
on
I
a shorter
mean.
path.
Yeah. We didn't
but
change.
sometimes the end of the wormhole ends up in a different universe, and it was all made of antimatter. It was very ugly. So,
Sort of like my first marriage.
Quick end, though. Yeah.
but what Bitfusion did have success at was setting up a pipeline. So you pay that penalty on the first couple of CUDA calls, and then while the GPU is calculating something, you're sending over the next batch of data, and it's sending back the previous results. Every ML application will have synchronization points, though, where it's waiting for a result before it will kick off the next batch, and so then you drain the pipeline and you have to restart it. Applications can be very different. The amount that you can batch up affects things, but we've done a lot to minimize the synchronization points to keep that pipeline full and to pay that latency penalty as infrequently as possible. Even so, there's guaranteed you're going to have a significant number of these synchronization points, and so it's important to
pipelines.
Yeah,
Sure.
So you want to keep the network latency as low as possible, and give that even more attention under Bitfusion than with the raw bandwidth of the network. So the sizing discussion, I would definitely pay attention. Don't skimp on the
Pate.
on the networking. Use large MTU sizes. And jumbo frames, and RDMA definitely performs better than TCP/IP.
Well, skips a lot of that stack. It's kind of like getting rid of SCSI in the middle of the storage stacks now. With NVMe and things. But there's one more question, and then I want to wrap it up. We're over time here, but this has been really great. I really appreciate you guys being on. I really appreciate everyone joining us who's been watching, and if you're watching after the fact, thank you very much. Clearly, we're not taking live questions after on a recording, but if you've got questions, leave them in the comments and that sort of thing. But licensing provided by VMware, I think there's a couple of different aspects to this question. So what's the licensing like for some of these things? I think we've covered a lot of the real world issues we might encounter, bandwidth and things like that. Any special training required for this? So why don't we start with licensing? What does the licensing look like on this? As much as I want to just kind of say, you should talk with your sales team about it. I think it's an add-on. Some of the stuff is an add-on to vSphere, right?
Right. If I can jump in here, if you use the vGPU model that I described as opposed to the Bitfusion model, then you pay NVIDIA a certain license for that software. Cool. It's licensed software that comes separately than the VMware. So we don't play in that transaction. That's a transaction between you and NVIDIA. So that's an alternative to using your GPU in pass-through mode, which takes away vMotion, takes away a lot of the DRS things in VMware. So I would take a look at vGPUs, and the virtual compute server is the product today to look at in the NVIDIA world. And Bitfusion is a separate form of licensing. I'll leave that to Jim.
Okay, so with Bitfusion, I think there's at least 3 bullet points, finger points that I want to make. So you can count at home and let me know if I seem to have forgotten something. First of all, we have a Bitfusion server and a Bitfusion client. Let's say this is the client. So the client doesn't need any licensing. You can just run your app there and it will use the remote GPU. The Bitfusion server does require licensing. First of all, the Bitfusion server owns the physical GPUs, And so you need to talk, and it owns them with Direct Path IO. So it is between you and NVIDIA as to the licensing to use Direct Path IO with those GPUs. Beyond that, second point is there is a Bitfusion add-on license for every 2 GPUs. It's in the hundreds of dollars. It's a very low price. There's various reasons we charge anything at all, but it's quite low. So you need a Bitfusion add-on for every 2 GPUs. And in addition, Bitfusion requires that your processors or that the host has an enterprise, a vSphere 7 Enterprise Plus license for every 2 GPUs. So if you have a host that already has 2 processors on it, and you have 2 vSphere 7 Enterprise Plus licenses to cover those 2 CPUs, that will automatically give you 4 GPUs, which should cover the vast majority of customers. If you went to 6 GPUs, 5 or 6 GPUs, you would need to purchase an additional Enterprise Plus license for that host.
Cool. Thanks. I want to get to the special training. If somebody wanted to start with this, or are there training? Does VMware offer training? I know nothing about this. I'm actually curious myself.
I would read our blogs first. That's a nice, cheap way to, if you look at core.vmware.com and search for GPUs, you'll find blogs there. Blogs.vmware.com, you'll find more blogs there that have the word GPU and that will take you straight to our machine learning world. Jim has published a lot in this area, I know too, and there are the hands-on labs at VMworld. If you happen to be attending VMworld, there are hands-on labs there that'll teach you a lot of this stuff in quick order. But I think, reading a lot of blogs was how I began to learn it a while ago, and that's a good way to find out more, especially on the basics.
With Bitfusion, we also have a couple of hands-on lab. Beyond that, there is no formal training. The installation and user guides are sufficient to get you all the way there. On the other hand, we're not unwilling to help people out. There's no training course though, but if you ask nicely and work with your SEs, we are training up more and more SEs so that they can just go in and do this automatically. On occasion, I personally have helped people, but that's not really my job description. So that's usually done under the guise of helping train the SEs.
Yeah, I know there's
Gelsinger at VMware.com, right? That's your email address. I think that bounces now. I'm not sure. But
no, that's cool. And I know there's a lot of resources out there because Jim, I know just in passing, I've seen mention of like the Jupyter notebooks and stuff like that, being able to do some of the stuff in a learning environment and setting that stuff up. I think there's a lot of open source stuff out there. You mentioned TensorFlow. What was it? PyTorch?
PyTorch.
Is that right?
It's another machine learning framework. Yeah.
And so checking those out. Justin, you say something?
If you're really at the beginning of this and haven't tried it in any shape or form, playground.tensorflow.com will give you a nice neural network to play around with.
Oh, really? Playground.
See, I'm making down.
Yeah. See, we're all
Google Playground TensorFlow, and it'll take you there. And it's a mocked up neural network that'll show you how these things work.
Oh, so really? My goal is to make it sentient and self-aware by what was the date in Terminator?
Oh, Terminator.
2024, I think.
We've already gone past
that. Already
I'm not
passed?
sure,
Didn't Skynet already go?
Depends which movie.
We
all know there are only 2 movies in that entire series, but I'm not sure which one.
Yeah, it actually has already occurred. We're just sitting inside of glass bubbles, providing a heat energy source for a super race of aliens instead. If I can mix my movie.
Yeah, I was say, like at least 3 movies together there, but
which probably means that's the truth. Like each one of these movies is again like the Socrates cave. We're just seeing little glimpses of the reality.
See the shadows on the wall. Yeah,
Plato, I think.
Play-Doh? Like, oh, not the things my kids
No.
play. Okay.
Play-
Yes.
Oh.
Allegory.
Plato's cake.
I think we're losing it here. I think that's a good place to stop this. I want to go around here again and just final thoughts. Let's see. Let's start with Justin. We'll go back around the other way. Justin, final thoughts.
I know this stuff seems like science fiction or science projects to some folks, and it seems like a future, but it's very much here. People are using this in banking, in insurance, in very, very practical ways on very practical data. So don't think that this is just about computer vision and self-driving cars and stuff like that. It's not just about that. It's got very practical business benefit today. And our contribution here is to bring this into the mainstream of the data center and make it non-mysterious anymore, make it a workload that you will feel quite comfortable managing with the tools that you use to manage VMware today. So that's what we're doing in partnership with NVIDIA and others, is democratizing this machine learning workload, making it a well-managed workload in the data center.
Very cool. Jim, what are your final thoughts?
Yeah, I'm afraid I'll just end up echoing here. But again, we are on the exponential. We're on the part of machine learning that looks flat. In retrospect, it is going to, maybe it'll turn into an S curve and be replaced by something else eventually, quantum computing or something. But it is going to grow like crazy, although it is here today. And for all of the, VMware started so you could share your hardware, use it for multiple operating systems, run multiple applications. And then a ton of side benefits come from that technology. You can do the backup, you can do the data recovery, all of these other benefits come from it. And we want our customers to be able to run these machine learning applications in the appropriate environment, with the availability, with the reliability, with the cloning, with all of this. And we want the flexibility. You can just spin things up and down as needed. So we are working furiously to just make it easier. And that's the role of the admin. Even if they don't understand all of the ones and zeros of these machine learning models, they certainly want to make it easy for their human overlords to expand their business and have great success, and someone's stock shares should go up, and
then you can retire and not worry about it anymore. Right?
Yes.
That just reminded me, data scientists shouldn't be managing infrastructure. They shouldn't be managing.
No.
It should be somebody else's
I
responsibility.
think vSphere admins tend to agree with you there.
Well, and vSphere admins shouldn't be writing PyTorch like that.
Hey now, yeah.
Stay to your lane.
Although we are going to use the vSphere logs to do machine learning with them and see what's going on. We are going to do that.
Ken, last thoughts. Take us out, man.
Well, again, that curve that we're on, I think that's the thing that's most interesting to me, is that this is such a nascent field still. The amount of data that's going to be generated, the ways we're going to use that data, and how we're going to automate the use of that data. I think, to Jim's point around quantum computing, these things are not mutually exclusive. The idea that around the corner we might have something like quantum computing doing our AI for us is pretty exciting, because the stuff that we'll be able to do with that level of power at our fingertips is astonishing. I mean, we're starting to get into sci-fi, but it's starting to look a little bit like Star Trek at that point, where the laborious work of knowledge workers, which today is something you need to train on, you need to become familiar with. We already have Watson that can kick my butt at chess. It's a better diagnostician than my doctor is. We have these capabilities that we're just starting to glimpse on that front. Well, what happens when we have a computer that's a better DBA than my DBA is, and so forth? And this is not a bad thing. This is a good thing, because it's going to drive efficiencies into the world as a whole that are going to be, unlock things that we just can't even imagine. And I think beyond the sort of practicalities of that, and everyone needs to be familiar with where this is going. And I think vSphere makes that easy for people to gain a platform that makes it easy for them to learn some of these capabilities, or at least become comfortable with the applications running on their own platform without having to re-architect and refactor everything. It gets you a bridge into that world that's coming. And the thing that has me most excited about all of that isn't necessarily, a better DBA than I could be, or a better, tech marketing guy or whatever. I mean, this stuff is about learning and improving. So we could honestly see a better Mozart. There could be beauty that can come out of this that we literally haven't even seen yet, because it's going to learn how to write the most beautiful music. And we say, that's a paw, not a whisker, but that's an 8th note instead of a 16th. You're a bad computer. And then the next time it's not going to screw that up. We're going to see artistic endeavors. We're going to see literature. We're going to see things that are going to unfold from all of these things that it's just unimaginable. And all that's going to need somewhere to run, and we're actually relevant to that space. It's pretty exciting.
Maybe someone will finally write the next book in Game of Thrones.
I'd be happy with the 5th Hitchhiker's, 6th. I don't know which one.
Guide to the Galaxy. Brain the size of a planet, and here I am.
Well, thank you guys. I really appreciate it. To everyone that's out there, appreciate you as well. Thank you for being our customers. Stay safe. Stay secure, patch your stuff. Like I said, I'm a security guy. And all this AI, I can't wait for William Gibson's, vision of hackers and ICE and all that stuff to AIs versus the ransomware gangs. I'd like to see that one.
Representing.
So cool. But thank you very much. Subscribe to our YouTube channel, and you will get notifications of this. There will be another one they tend to be the end of the month, end of August as well. I don't know the topic right now. We kind of choose the topic between now and then. But stay tuned, and thank you very much. Take care.
Thank you.
Bye.